I think I learned programming fairly late because a lot of people of my age, I think, started when they were like, teenagers. I did do a little bit of programming when I was in middle school, which was on a TI calculator. And I wrote some like games on the TI calculator. And I remember there was one game where we wrote it with a teacher mode. So if you were playing the game, you'd just press a button and then it would appear to be like the regular calculator and you could put in math and whatnot. So if your teacher came over, you could be like, oh no, I'm doing my stuff. But then it would save your game state so you could just go right back. So technically my first programming language was BASIC, which is what you program the TI in. But then I got into C++ and really into my programming journey when I was 19 or so. And I played these text-based online games called MUDs when I was a teenager, and I got really into them. And they were always these sort of like community-run games, like somebody would just host it on their server, and I wanted to create my own MUD. And one of the people who ran one of these other games, he gave me some very sage advice, which is he told me, look, if you're gonna do this, you can have other people who are helping you out, but you shouldn't be unable to do any task. You should be able to do all of the work that you would need to. And so that means that you need to learn how to code, because you can't just be, in charge of this coding project and not know how to code. Because it's really hard to find people who can code who are going to want to give their time to this project. And so you should be able to do all of it. Maybe you get some other people to help you out, but you should learn to code. And that's why I started learning to code. And I was working with one other guy, and we started writing it in C++, and a lot of these were written in C at the time. And he introduced me to Boost, the Boost libraries. And we were using one particular Boost function, which I think was something in Boost string algos, which is a library that I doubt is even still around. And I found a bug in it. And then I was like, oh, well, I should go fix this. And I submitted the fix to Boost. And then I very quickly got sidetracked working on Boost. And that's sort of the how I got going. And then I was in college at the time, and I you could say I dropped out of school, but technically they kicked me out of school because I just stopped showing up to classes. And I went home, and my parents weren't very happy. And I know I needed to go get a job, and so I spoke to some of the Boost people on IRC, and this one guy who'd been mentoring me, Hartmut Kaiser. I didn't know his name at this time. He was just an IRC handle. And I told him, hey, I need a job. And he tells me, well, you should come down to Louisiana and come work at my research center. And I made this proposition to my parents that, hey, I met this random guy on the internet. I want to go take a one-way flight to go work for him. And I managed to convince them that this guy was not, a serial killer. And I went to go to work for him. And I worked at his research center for about 6 months. And then the head of his research group was moving to a different institution, and Hartmut wanted to stay, and so we started our own research group. And that ended up being successful, despite the fact that I was like a 20-year-old college dropout and had no business to be, helping to start a research group. And eventually he convinced me to go back to school, and I got my degree there. And then I worked for Berkeley Lab for a while, which was a US government lab. And then after that, I went to NVIDIA. I would say that my time working with Hartmut has probably been the biggest impact on me. So I think I had the rare opportunity of having really an apprenticeship. I did not learn programming in school at all. I got a degree in math when I, finished my degree at LSU, and I explicitly decided I didn't want to get a degree in CS because I knew I was very arrogant and headstrong at the time, and I figured I was going to clash with all my professors. I was going to think I was smarter than them, so I figured I'd get a degree in math. But that meant that I did almost all my learning from Hartmut. And he'd been, in the field for 20 years or so. And he was an educator, so he was a really good teacher, really good at guiding me. But we were also, working together. We were, developers 1 and 2 on this project, HPX, which was this parallel runtime system. And I spent a lot of my early, coding years working on this project. And a lot of my like philosophy of programming and a lot of what I call my like parallel programming mindset comes from what Hartmut taught me. And he would always view problems with a very different lens than other people, and he would always question things that other people would just sort of assume to be the evident truth. He'd be like, well, what if we just flip this whole thing on the axis? What if we did this? And like, maybe this would seem to most people like an unreasonable thing. But he had asked the question. And that's been like a big part of why I think I've been successful, because I'm never afraid to ask questions because I saw him do that. And he taught me a lot about coding style and design. A lot of my design sensibilities, I think, come from him. Yeah, so I think my career has largely been going from mentor to mentor. Probably my next substantial mentor was Olivier Giraud at NVIDIA. And when I joined NVIDIA, he was the person who convinced me to go to NVIDIA. And when I joined NVIDIA, he'd been there for 13 years or so. And so he knew where all the bodies were buried. And he worked in hardware architecture. He wasn't necessarily a software guy. But it didn't really matter, because when you've been at a company for 13 years, you know everybody. And so we would meet and chat very regularly. And just having somebody in my company that had been there for so long and that was so well connected, it meant that like I had a jump start on everybody else who was a new hire, because I could always get connected with the right people, and I could always it wasn't just about the technical work too, but like, figuring out how to get promoted and things like that. He knew, because he'd gone through all of it. He knew how to guide me. He knew how to, he understood the culture of the company, and he was able to teach that to me. He understood the politics of the company, was able to, help me navigate that. And I don't think I would have been as successful without somebody like that. And so I always tell people to try to find, like, don't look for jobs, look for mentors. Look for, if it's either a job or a school, you should be looking for, who am I going to be working with? Who's going to be my guru? Who's going to be, showing me where all the bodies are buried at this particular institution? So I I get asked this question a lot, and I sometimes joke that I'm like a software executive producer. I come up with the big ideas, and then I work with the engineers, the talent, the actors, if you will, to put it together. And I'm not necessarily the director, of the movie, or the the person who's going to be on stage, but I'm sort of there to solve whatever problems are going to come up and set the overall direction of the thing. And what does that mean in terms of my day-to-day job? I spend a lot of time designing things at a high level. I spend very little time day-to-day coding. And I spend a lot of time mentoring people, a good chunk of time in meetings, a good chunk of time like strategizing. My particular role as a principal architect, I work on programming languages and in the exposure of our platform, NVIDIA's compute platform, into various different programming languages and also libraries in those languages. So it's like, okay, we've got this new generation of chips, and this new generation of chips has this quirky, feature or accelerator. Like, how are we going to expose that up? Or like, how are we going to make it so that we can actually write code for this platform? And historically, I've mostly worked in C++, but increasingly, I work with lots of other languages like Python and even Rust. And part of the role, I'm working with people who are on the the user side, so people who are actually writing the code, figuring out what they want. But then I'm also working with the engineers who are writing the compiler, who are actually developing the programming language, and then also the engineers who are developing the libraries and the tools and the frameworks and the APIs that are going to be written in that programming language. The code that I do write, I find the most frequently is either example or pseudocode. And I jokingly say the only code I'm going to write is going to be like the code that will fit on a slide. But the reason for this is that when I'm writing code to figure out what the programming language or what the interface should look like. And it's an experiment. If I write, 10,000 line example in a particular style, but then a week later we decide it should actually work this way, not that way, then I've got 10,000 lines of code to rewrite. What I want to be able to write code that's going to be short but impactful, and that can help me learn what's the right design going to be. And I oftentimes, when I'm designing something, I start off with writing the examples. In the same way that, the best practices, you should start off writing the tests. If I'm designing a new programming language or a new feature, I start off writing the examples because looking at the examples, thinking about what I actually want to write, that's going to lead me to, figure out what the interfaces should look like and what do I need to actually support. And it's every time I do that, I realize very early on that assumptions that I'd had about how this would look are wrong. That, I need to actually have it be this or that, and that it uncovers all sorts of problems writing the code in this way, where I start off with examples, and then once I've written some of the examples, then I'll start writing a design document or a specification. So that's probably what I spend the bulk of my time doing, is writing a specification of some form. I've historically done a lot of standards work, working on the C++ standard and some other language standards, some other tech standards. And so when I'm writing a design document, I almost always write it like a specification, not with strictly formal language, but I like to think of it like a little mini standard. And I like it to be something that's self-consistent, and that we can eventually turn into the actual spec that we will, ship out to users. So it's hard for me to really say what other companies are like versus NVIDIA, because I have been there a long time, and it's been really the main, corporate environment that I've been in. I really love the NVIDIA culture because NVIDIA does not have a lot of strict hierarchy or rules. It's very freeform, very flexible. I sometimes describe it as it's a little bit of organized chaos, which I really like. My boss sometimes describes me as I'm like CUDA special forces. I get sent wherever I need to, and I get deployed into some problem or some team. And they're it's never a problem where they're like, okay, here's this person from some other part of the company that's going to now work on this thing or help out with this thing. And that freedom and that flexibility is really valuable to me. It really works well for my my personality type. I think that for some people it could be quite scary if you're you start day one at NVIDIA, and usually it's like, okay, here's a laptop and here's a pile of bugs you're responsible for, good luck. There's not necessarily a lot of structured onboarding. It sort of depends team by team. But if you're a self-starter, if you've got a lot of initiative, it's a great environment for you, because people aren't going to tell you no without a reason. They're not going to be like, oh, you can't do that because that's not your job title. You're not going to hear that. If you get a no, it's going to be like, oh, no, we can't do that because there's a specific technical or business reason for that. NVIDIA's got a very flat management structure. A lot of decisions are engineering driven. A lot of people in leadership come from a deep engineering background. Our CEO has been, the founder of the company has been there for a long time. He has a really great long-term vision. He's very loyal to the employees, and I think that a lot of employees, myself included, are very loyal to the company because we've seen how the company treats us during both good times and bad times. I increasingly find that when I do write code, it often ends up being not the best bang for buck. If I go off and spend like 3 weeks of time of like 100% of my time like writing code, like during that period of time, I could have enabled 50 people to do like to unblock 50 people to do their jobs better. Like an hour of my time spent advising or mentoring, somebody that could change their whole week. And I didn't really realize this until a couple of years ago when there was like one particular meeting that that I had like been skipping going to because I was like, I got too much work. And the director of our HPC compiler org and my boss sort of told me like, hey, look, like you gotta come to this meeting because like the things you say at this meeting like set the direction for that team for like the next week or 2 or 3. And like if you're not there, like they're gonna either make worse decisions or they're gonna be at a loss of how to approach this problem. And so if I am gonna write code, it has to be something where the investment of time is gonna feel really high impact for me. So usually I'll only write code if it's something where I feel like there's nobody better equipped to do it at the company than me. Generally, for individual contributor work, I never want to, like, I always joke about this at the company that it's always a problem if I'm the most knowledgeable person at the company on a particular topic. I should never be the most knowledgeable person on a particular topic. If that's the case, then, like that's maybe indicative of a problem. And so I should never, I feel like I never should be the person who's best equipped to write a particular piece of code. Of course, in practice, it does happen sometimes. So, I mean, I try to, I don't go out of my way to write code. I feel like if there was a year where I didn't have to write any code at all, I think I'd be fine. I don't really count the like examples or pseudocode that I write as being like writing code. I mean, talking about like writing a PR for like, a production thing. If there was a year where I didn't write a PR for a production thing, that would be perfectly fine. I've never gone a year where that's not happened. Usually there's like some minor things. Most commonly, I'll write code if I'm doing an experiment and I have to write code to unblock myself for the experiment, then I'm going to do that because the cost of me having a context switch to other work while I wait for somebody to write the code that's going to fix my problem is too high. So if I'm blocked by something and it's not fixed and I can fix it, I'll go fix that thing. And then, if I've done that work of writing that fix, I may as well, push it upstream to the code base. I know that some people who are in this sort of role feel like they need to write code to, stay current. I don't think that that's the case because if you're in a leadership role, you should be reviewing other people's codes. You should be talking with engineers. You should be, looking at what their problems are. If you're in a one-on-one with somebody and they're like, oh, I have this problem with this code, you should be like, okay, let's look at it. We can look at it together. And so you should be doing a lot of that, and through that you can be staying up to date. But I mean, I know I think I'm a little bit rare in this case where a lot of people feel like, oh, I wish I could just spend all my time coding. I don't want to spend all my time coding. I prefer to spend my time enabling people. So I would say that for junior developers, I think probably the 2 most valuable skills to have is writing and communication. Especially with the emergence of large language models, it's going to become even more important to be able to communicate your ideas and your thoughts. And the second is math. I think pure mathematics is sort of a timeless field, and it's a timeless skill set. While there may be a future where we humans do a lot less programming, the fundamentals that you learn in math are always, I think, going to be relevant, and they're going to be relevant to how we design things and how we build things. I think that it's a very challenging time for young programmers. We saw post-COVID with a little bit of the tech pullback. We saw a lot of tech companies pull back on hiring. And the reality is that most of the big tech companies have the luxury of just hiring senior people these days. So it can be very difficult to get started for younger programmers. I think the best option is to have internships. Like if you want to get a job as a software engineer, you need to have internships essentially every year that you're in college. And I think I am generally a little bit more skeptical these days of people getting masters and PhDs because there are so many people who have them now. And because of the 2008, 2009 recession, and also to some degree because of COVID, there's just a lot of people who just said, I'm just going to continue and get my master's or my second master's or a PhD. And because so many people have them, it's got a little bit less value. And I think that almost the time in industry would be more beneficial. If you're already doing a master's or PhD program, I think it's worth it to see it out to the end. But if you're, an undergrad and you've got good internships and maybe have, to choose between a master's program or going into industry, I think it's better to go into industry because if you graduate as a master's student or a PhD student with no industry experience, you're going to be competing with the pool of people that are looking for more junior positions versus going and getting 2 or 4 years of industry experience. Then you're going to be competing for the more senior jobs.